Welcome. In this video, I will be introducing our dataset, giving a background on the t-test, and giving an introduction to t-testing in Julia. Our particular dataset was a CSV file which contained information on a number of product orders placed at a superstore. There were a total of 9,426 orders placed. The original dataset included 22 different variables. It is a mixture of both quantitative and categorical variables. The quantitative variables included, but were not limited to, unit price, discount, shipping cost, quantity ordered, sales, and profit. The categorical variables included, but again were not limited to, order priority, the individual customer, customer segment, shipping mode, product category, product subcategory, and product container. The dataset indicates that 52% of the orders were profitable, while the other 48% obviously were not. It also indicates that 20% of the orders were in the consumer segment, 36% were in the corporate segment, 24.5% were in the home office segment, and 19.5% were in the small business segment. Now, let's learn about the t-test. First, a little background. The t-test was introduced by the English chemist and statistician William Seeley Gossett in 1908. Because he worked for Guinness Brewing Company at the time, and they forbade their chemists from publishing their findings, he published them under the pseudonym Student. This is why it is often referred to as Student's t-test. T-tests are a special case of ANOVA. The types of t-test we will be demonstrating are the one-sample t-test and the two-sample t-test. The one-sample t-test finds the difference between the sample average and a hypothesized population average. On the other hand, the two-sample t-test finds the difference between the averages of two different samples. ANOVA, or analysis of variance, is a collection of statistical models and their associated estimation procedures used to analyze the differences among group means in a sample. The t-test follows the form T equals Z over S. This can be broken down further to equal x bar minus mu, all divided by sigma over the square root of n. X bar equals the sample mean, mu is equal to the hypothesized population mean, sigma is equal to the estimate of the standard deviation of the data, and n simply equals the sample size. Plugging the values you are given for the aforementioned variables into the above formula will give you a t-score. The probability of rejecting the null hypothesis for that t-score can be found using a t-chart and finding the corresponding percentage level for the calculated t-score with n minus p degrees of freedom, with p equal to the number of parameters in the test. As Professor Roman has taught us, statistics is all about assumptions. In order for a given statistical test or model to work, we must first take a number of things as given, and t-tests are no exception. For one sample t-test, we must assume that x bar follows a normal distribution with mean mu and variance sigma squared over n. We must also assume that s squared follows a chi-squared distribution with p degrees of freedom under the null hypothesis, where p is a positive constant. Finally, we must assume that z and s are independent. For two-sample t-tests, we must assume that the mean of the two populations being compared follows a normal distribution. If using Student's original definition of the t-test, we must also assume that the two populations being compared have the same variance. Finally, we must assume that the data used to carry out the test is sampled independently from the two populations being compared. Now, we move on to Julia. To get Julia to run, you must first install an Integrated Developmental Environment, or IDE. We used the Juno environment in Atom, but you can also use it in Julia Pro. In order for Julia to run the functions we want it to run, we must first install the packages we need. Installing packages in Julia is simple enough. In order to do so, you type the command pkg.add parentheses the name of the package you want to install. There are numerous packages available in Julia, but for our project, we only used 5. The 5 packages we used were data frames, stat plots, hypothesis tests, distributions, and plots. Data frames helps us deal with tabular data. Stat plots and plots give us functions that help us graph our data. Hypothesis tests implements a wide range of hypothesis tests that you can use. And finally, distributions gives us functions associated with probability distributions. Before you can run any tests on your dataset, you must first read your dataset into Julia. In order to do this, you must first make sure that your file is in your working directory. This can be found by clicking on the Julia tab, scrolling down to Working Directory, and then clicking Select. Once the file is in your working directory, it can be read into Julia by using the command readTable parentheses name of your dataset. Don't forget to add the suffix to the end of your dataset name. For us, it was .csv. Let's say we wanted to perform a one-sample t-test to determine if the mean profit of all the orders in our sample is equal to 0. We can subset our data by creating a vector that contains the value of the variable profit for all 9,426 orders. Then, using the command oneSampleTest, we can implement the vector that we just created and set 0 as the null hypothesis in our function. When we run that line, we get a confidence interval, a hypothesis test, and a p-value. Using the confint function, we can also create confidence intervals, changing our alpha level and number of tails as we see fit. Common plot functions we have used in R, such as QQnorm, QQline, and boxplot, also exist in Julia. These functions allow us to visualize our data, look for outliers, and help us determine whether or not to reject our null hypothesis. Julia can also be used to perform ANOVA. Just like in R, this is done by creating a model using the fit command and then using the command ANOVA parentheses name of the model you just created. Julia can also do two-way ANOVAs by creating 2 models and then using the command ANOVA parentheses first model, second model. In conclusion, Julia, like most programming languages, is easy enough once you get the hang of it. The commands and functions on Julia closely parallel those of R, which those of us who are in Stat 610 have likely all been using for years now. In our next video, we will be going more in depth with 1 and 2 sample t-tests in Julia, as well as ANOVA in Julia.